so let's let's start right where we ended from. So we have the domain, the range we said was going to be between 1 and -5. So multiple ways. You can either write that it's between 1 and -5 like this, or 1 and -5 like this. Okay, and then last up, so for the domain, so the x value, if we approach it from the left, the smallest x value I see is -4. And then the largest x value will not exist because it continues increasing. So all the x values are going to be greater than or equal to -4, which you could also say like -4 to infinity or -4 to infinity written like this. And then for the range, so if I come from the bottom of the y values, the first y value I see is here at 0. So it's from 0, and then if I keep increasing, well, this will keep increasing. And in fact, we're actually going to learn this might not keep increasing, but for the sake of today and what we're learning, let's say it keeps increasing towards a large infinity. So we're going to say y is greater than or equal to 0, or 0 to infinity, or like this. Okay. So the other thing I want to mention is a piecewise function. So we're not going into great detail about piecewise functions right now. Specifically, this is an example of an absolute value function. All it means is that this graph is actually made up of two different graphs that only exist over certain domain and ranges of the graph. Okay, so this might look like something that is multiple graphs pieced together, which is why it's called a piecewise function. Okay, so let's look at this one. So we have three different graphs that all exist on different portions of the physical graph. Okay, so let's start off with a calculation, then we'll get to actually how you would graph this. So 2x is the part of the graph that's between 0 and 2 combined. So here it says I want to find f of 2, which is, remember, that just means the x value is 2. Well, the only region of this piecewise function that touches 2 and includes 2 is right here in this first section. Okay, so you actually can't do the calculation here or here because x equals 2 doesn't exist in this domain or this domain. So to find f is equal to 2, we're going to take 2x, which is the function, and replace x with 2. Okay, so f of 2 is 4. If we want to find f of 3, well, this time it doesn't exist in this domain, but it does exist between 2 and 4. So we can do the second calculation in this second part of the graph. So f of 3, so we're going to plug 3 in, but there's no x there. So in fact, when you put f of 3 in, or an x value of 3 into this portion of the graph, you're going to get 4 as an answer. And the last one is 7. So again, 7 is not in this domain or this domain, only in this one. So I'm going to plug 7 in where I see x and solve. So we're going to get 7/2 here. And again, I'm showing multiple steps, not necessary if you feel okay with fractions to do this without the step. So 4/2, which is 11/2. So now let's get to trying to graph this with what we know. Okay, so we want to sketch the graph. So I like to take this one question at a time. So let's start with graphing 2x. So remember, that's the same thing as y is equal to 2x plus 0. So the y-intercept is 0, and the slope is 2 over 1. So up 2 over 1. And I can continue that graph forever. But because the domain here is between 0 and 2, I'm going to start at an x value of 0, and I'm going to stop my graph at the value 2. And it's included. Okay, so I'm going to create a solid line that attaches to represent this portion of the graph. So I'll write here, this is the blue portion. Next up, let's do this. So between 2 and 4, Okay, we have a value of 4. So it's not, there's no slope, which means it just stays at a value of 4 throughout the entire 2 to 4 domain. So from 2 to 4 here, the y value is 4. Okay, so that one we represented with red. And then this last one here, this is y is equal to 1/2 x plus 2. So I am going to start, and I'm just going to trace really lightly so that you can't really see. So we start at 2, and then a slope of 1/2, 1/2. Okay? And then it says that this goes from 4 to 8. So I'm going to continue this trend all the way to 8. So 1/2, 1/2. So we're at 8. And I'll attach this with a line. And so this is an example of 3 functions that make up a piecewise function, each with a different domain. Okay, we're on to the last one. Thanks for your patience. So this one, it says the path of a golf ball after being hit by a club can be modeled by a function where t is the time in seconds and h is the height of the ball in feet. And sorry, I just included the function there for us so we can actually see what's happening. So with this, it says use your graphing digital calculator to sketch the graph of this ball's path. So remember when you're putting this in your graphing calculator, start by clicking y is equal to and placing the function there under y1. Also a reminder, even though we have h's and t's here, when you're putting it in the graphing calculator, it's only going to use x's and y's. So place it in as y is equal to 60x minus 16.1x squared. Okay. Once you're done that, you can either click graph or you can play around with the window or the zoom to make sure that you have full access to seeing the graph. Okay. Once you've played around with it, you can change the maximum, the minimum x and y values. You should see something that looks like this. Okay. And what we know is that we have time in seconds and height of the ball. So time is going to be our independent variable in seconds. And height is our dependent variable, and that's in terms of feet. So that was the first one. We labeled the axes. Now, why is this graph considered a function? Well, if I take a line and I place it through, this passes the vertical line test, which consequently states that it is a it is a function. Okay, so we are good with that. It passes the vertical line test. Next, use your graphing calculator to find the t-intercepts, just another way of saying the x-intercepts because our x is a t in this question, and the maximum value. So, as a reminder, to do that, you click second, trace, which you should see calc written above trace. Okay? And when you want to find these intercepts, they're the same thing as known zeros. So you're going to scroll down to 2, click 0, and it's going to ask for a left bound and a right bound. Okay, make sure you're to the left of the point you want to find and then to the right, and then click an extra enter to find the value. So this one is at 0. If you do it over here, you're going to find that it is touching at, let me just plug it in here, 3.73. Okay. And then to find the maximum, again, click second trace for that calculation. And number 4 says maximum. Again, it'll ask for a left and right bound. When you do that, you will find that the maximum height value, or the y value here, is 55.9 feet. Okay. I would be very explicit in this question and state t is equal to 0 seconds and t is equal to 3.73 seconds, along with h is equal to 53.9 feet when they're asking for a maximum. So don't just place it on the graph, but yes, it is important to have those values on a graph if it's asking for a graph, but to include them explicitly. And then last up, what is the domain and range? So our x values, from the left, they start at 0. From the right, they end at 3.74. So the domain is between 3.73 and 0. Or again, you can write it like so. And by the way, I've taught French for many years, so you'll see I often write a little comma. It should be a dot. So do as I say, not as I do. In that case, you should be putting a point in for the decimal. For the range, well, the minimum, if we come from below, it starts at 0 and it ends at that maximum. So it's going to be between 0 and 53.9. Again, you can write it like so as well. And sorry, I should be writing 55.9. That was my mistake. Just me not reading my own writing. And that is it. So try to tackle some of the problems, and we can review anything that you're confused about from today or yesterday, tomorrow in class, oh, sorry, Monday in class. Have a great weekend.